compare two very similar looking expressions. Notice I've got the square root of 9, then that whole quantity is squared. And on the right I have the square root of 25, then that whole quantity is squared. So this will help in building one of the fundamental formulas for roots. And we're going to do this for square roots and then just say that the same general behavior has to work for third root and fourth root and so on. So first off, what I'm going to do is let me leave the set of parentheses on the square. So I only want to simplify what's inside these set of parentheses right here, and I'm going to write my result inside this set of parentheses right now. And what I do have in parentheses is the square root of 9. And the square root of 9 I happen to know happens to be 3. Same deal here. So let me draw the quantity squared. So I've written that part. I just need to write what's inside the parentheses. Again, what's in the original set of parentheses, I am now going to simplify and write inside parentheses. And the result of the square root of 25 in the parentheses is just 5. Now let me rewrite each of these equations right underneath. So I had in parentheses, I had the square root of 9, and then outside of parentheses, I have this square. Let's erase that. And on the right side, I will simplify. So this 3 squared that was there, I'll write a 9 instead. Now you can ignore what's up here. Now, same deal. I'm going to leave the left side as is. So I have the square root of 25. On the right side, it says 5 squared. Well, 5 squared happens to be 25. So now I'm going to ignore that line. But let me just again reveal. What I did was the 5 squared is equal to 25. I'm now covering this. I don't want you to look here anymore as long as you agree with the fact that this simplifies to the 25 down there. Then there's no need to look up here. This ends up becoming a visual distraction. The thing that we now see in common in both of these, the pattern to notice is that in both of these, we can say that the second root of a number, the second root of a number squared. So that number in the first example is 9, and the second example is 25, and generally I'll just use an A. That is going to equal, and it's easy to get confused here and say that you should have A squared or something like this, but if I highlight in blue the thing inside the root symbol is the 9, so I underline 8 here. In this example, that's 5. Notice that all you have on the right side is either 9 or 25. The general pattern to notice here for this is 3, right? So if you want, let me just put this in a box and this in a box. If you ignore the contents inside any of the boxes, you should see the same general shape and pattern here. So again, to write down this formula, what we have is that I'm going to write down this formula just down here. We have the second root of A, all raised to the second power is equal to A. Similarly, we won't go through it, but it's a similar line of argument. Third root of A raised to the third power is also equal to A. The fourth root of A, the fourth power is equal to A. And now we can summarize all these in general. The point is, even though we'd have a different argument for each of, or slightly different argument for each of these, I'm not expecting you to go through the argument for the fourth root, but if we summarize what's going on all together, here you see that a square root and a square cancel each other out. That's what you see here you see a cube root and a cube cancel each other out, and here you see a fourth root and a fourth power cancel each other out. The general pattern is that an nth root and an nth power cancel each other out. This is how we develop this pattern. So we did quite a bit of work up here originally. Notice, this general pattern, which was stored like this, that was this. We said a similar argument would try these, and then noticing the general pattern again, we get a formula.